Alright, this video is on isotopes and isotopic notation. And in this video we're going to talk about what isotopes are and how we represent them in a chemical symbol, specifically isotopic notation. So first thing, isotopes. An isotope, isotopes are atoms of the same element with different number of neutrons. Now, it's important to know that this is going to be one of the first instances where Dalton's atomic theory is going to be refuted. Okay, atoms of the same element should all be identical according to Dalton's law, Dalton's atomic theory. But in this case, we have isotopes. Isotopes are the main reason why Dalton's atomic theory is not universally accepted. Okay, and the reason why is because with a different number of neutrons, okay, that means no two atoms of the same element are identical anymore. Okay, for example, if I had, say, carbon-14, and I had carbon-12, these numbers right here represent the mass number. Okay? Now the mass number is the number of protons plus the number of neutrons. So the what we call the nucleons. Okay, because both of these protons and neutrons are found in the nucleus, so we call them collectively nucleons. So the nucleon number, or the mass number, is indicated by this number after the name of the element. So carbon-14, carbon-12. Okay, if we look up here, carbon, looking at the periodic table, we determine that there are 6 protons, which means if there's 6 protons and it's a neutral atom, there must be 6 electrons as well. And if it's carbon-12, that means that this number right here represents the number of protons plus neutrons. So if the number of protons is 6 and I have the mass number of 12, that means I have 6 neutrons. Now they have specific symbols or names that we can use to identify how to go about finding the number of neutrons. This right here is the atomic number. That is found on the periodic table. It is the, on your periodic table, the whole number that is above the symbol. Okay, so for example, over here in the corner, carbon would look like this, carbon-6. And then on the bottom, you'd have your name, in this case, carbon, and then you'd have a number. And that number below is the mass, or the average atomic mass. Okay? Now, the atomic number is the number of protons. The mass number is the number of protons plus neutrons. The atomic number has a symbol, Z. The mass number has a symbol, A. So if I want to know the number of neutrons, it is equal to A minus Z. Okay, so if I was to take A, which for carbon-12 would be 12, okay, let's go ahead and erase this. So A for carbon-12 is 12, and then Z for all carbon is 6. I would subtract the 2, and this would give me 6 neutrons. If this was carbon-14, that means this would be 14. This number right here, the Z, doesn't change. It's still 6, because if it's not 6, then it's no longer carbon. Okay, I subtract these two things from each other, and I end up with 8 neutrons. So here I have 2 different elements, carbon-12 and carbon-14, and they each have the same number of protons, they each have the same number of electrons, but they have different number of neutrons. which means that these two elements are not identical. Or sorry, these two atoms of this element are not identical. Okay, which, like I said, is going to debunk one of Dalton's atomic theory postulates. Okay. All right, isotopic notation is pretty simple. Your symbol, okay, is going to be your symbol, which, like for carbon, would be C. Okay, and then you have your mass number, which is the number of protons and neutrons. That's A, and that's written in the pretty much think of it as an opposite or a superscript that comes before, and then the atomic number, which is the number of protons, is the subscript that comes before the symbol. Okay, so for example, if I was to take this and I was to do it for, say, carbon 14, it would be carbon, and then the atomic number is 6 for all carbons, so I put 6 there, and then I would put the mass number, which for carbon 14 would be 14. Okay? So, you may also see something like this. You may just see carbon and then 14 like that, and they don't really put in the atomic number because it's implied with that symbol. So everything that has carbon is always 6 protons. Okay? And then, of course, another way to write this would be how you first saw this, which would be carbon 14. Okay? So those are the 3 ways you'll see the isotope carbon 14 written. It'll be written like this, or like this. But in every case, they mean the same thing. Okay? Okay, a couple quick examples for you. What I would like you to do is, on your notes, okay, draw these 2 diagrams, and then for each of the diagrams, I want you to give me the isotopic notation. Okay, so go ahead, pause the video, do that real quick, and then I will unveil your answers, which are, or reveal your answers, which are below, circled in black. All right, so pause the video, go ahead and do it real quick. All the information that you need is right there. Okay, so we have 11 protons, which means it is sodium. The symbol is Na. Oops. Na. And I have 11 protons and 12 neutrons, which means my mass number is 23, and my atomic number, because I have 11 protons, is 11. Were we right? Oh yeah. Okay, this one over here, still sodium because I have 11 protons, which means my atomic number is 11. And then I add up my protons and neutrons, so that'd be 24. And this should be the isotopic notation for sodium 24. Is it? Oh yeah. Okay, so any questions? Make sure you ask in class.